Today we are going to be factoring a GCF. So this is what we've been building up to. Yesterday was pretty much a review day of things we've already talked about. So that way today we can factor a monomial from a polynomial. For our warm-up, first one, which of the following are not polynomials? Which ones are not polynomials? Jasmine? D is not a polynomial. There's only one term there. So that is not a polynomial. Any other ones not a polynomial? Oh. So we're thinking about which ones are not polynomials. C is not a polynomial. There's only one term there. Which other one is not a polynomial? A. All of these only have one term. Okay, so we determine where our terms are based on plus or minus signs in between them. So since there's a plus sign in between the -6 and the xy, that is a polynomial. All right, on number 2, which ones are not polynomials? I would say all of these technically are polynomials. They all have more than one term. None of the terms can be combined. So I would say that we shouldn't circle any on this one. Okay, so 2a and 6, 2 terms, can't be combined. X squared and a y squared can't be combined. These ones also can't be combined because the exponents are different. Different variables can't be combined. So I would say all are polynomials. All right, 3 and 4 are probably pretty easy for most people. What do you think belongs where the question mark is on 3? A 2. Okay, when we add fractions together, so the question mark here is a 2. When we add fractions, we need a common denominator. So if we're taking 1/8 plus 2/8, that's the same as 1 plus 2 all over 8. So what do you think goes in place of the question marks on number 4? 2 and 4. So again, if we are adding fractions with a common denominator, we can just add the numerators, keep the same denominator. That's a property that we're going to be using in our notes today. Find the GCF. So this is something we did yesterday, GCF of monomials. What is the GCF of 2xy and 6x? 2 is part of it. What else would be part of it? So if we were to write out 2 times x times y, there was nothing really we could break down there, right? If we were to break down 6, what would it break into? Okay, so 2 times 3, and then it also had an x. So when we look for a GCF here, what are we looking for? Pairs or matches, things that are the same. So what's the same? 2's and x. So 2 is part of it, but also x. 3 is not part of our GCF. 3 was a factor of 6, but there wasn't a pair of 3's. You have questions about finding that GCF? Yes.
So when is it that you have to multiply all of them all together?
That would be this case, but there was nothing really to multiply. So like if the top had also had a 3, then we would have multiplied the 2 and the 3.
So you don't multiply the 2 and the 2 to get 1?
No, because remember for each pair we only use one of them. So we had a pair of 2's, we used 1, 2. Other questions? Okay, so let's try doing that for 6x cubed, negative 4x squared, and 10x. I'm going to take away number 4 so I've got some space to write. If we're writing out our list for 6x cubed, what would it look like? Good. 2 times 3 times x times x times x. So x cubed, we'd have 3 x's. For negative 4, what multiplies together to give us negative 4? Negative 2 times a positive 2, and how many x's? 2 of them. All right, what would we multiply together to give us 10? Okay, so 2 times 5, and that one would have how many x's? 1 of them. Questions about those lists? Okay, so what do they all have in common? Okay, they all have a 2. What else do they all have? An x. They all have an x. Okay, so that would be the only thing that they all have in common are a 2 and an x. Questions, concerns about that one? For sure? Okay, on we go. To divide a polynomial by a monomial, divide each term of the polynomial by the monomial and add the results. So we're going to be splitting up our polynomial and dividing each term one at a time by that monomial. And then our answer will be another polynomial because we'll add those terms back together. Anybody need more time on that box? Got them filled in? On we go. All right, so we're taking this polynomial, 5m plus 35, and we are dividing it by 5. So this is why this was in our warm-up. We could split this up and take 5m divided by 5, and we can take 35 divided by 5. Okay, there was a plus sign in between them, so I'm putting a plus sign in between them. We're just breaking it up so that each term of the numerator gets divided by the same denominator. Then we just need to simplify these. 5m divided by 5, what does that become? 1m, or just m, plus 35 divided by 5 is 7. Easy peasy. Each term from the numerator gets divided by the same denominator. You ready for number 2? Okay, so let's try it again. This time, what's one term from my numerator? Okay, and that's going to get divided by what? 13b. Plus, what's the other term from my numerator? 39b also gets divided by 13b. Okay? So we need to simplify both of these. 26 divided by 13, what is that? 2. What cancels out there? The v's will cancel out, leaving us with 2u. Plus, on the other one, again, the v's are going to cancel out. 39 divided by 13 is 3. So 2u plus 3. Questions, concerns, need more time? All right. On number 3, what is one of our terms?
What? You kept moving.
What is the first term here? X cubed y gets divided by xy. Okay, now what symbol do you think I need to put next? Subtraction, because we have a minus sign here. So I'm going to use that minus sign. What's the next term after the minus sign? 4x over xy. What symbol comes next? Plus, next term, over xy. On the first term, the y's would cancel out. How do we get x squared? Good, we're dividing the same base, so we subtract our exponents. Minus, what happens in the middle term? The x's cancel out, and what are we left with? Careful. 4. The y is by the 4? It's under it, so it's y over, 4 over y. Does that make sense? The y is doesn't have a reason to come up here.
So if it's not flipped it, they have to
Right, the 4 was on top, the y was on bottom. They're going to stay that way. On the last term, what cancels out? The y's, and what are we left with? 6 over x. Again, I use that plus sign. Questions, concerns? Need more time? It gets we go another step further after dividing. Nothing on number 3? Okay. Number 4, what's my first term? Good. What comes after that? Very good. What does this simplify to become? There we go. All right, we've got one more. Okay, on this one, my first term, 3x to the 4th gets divided by, okay, minus, my next term is what? 9x cubed y gets divided by negative 3x squared. After that would become what? Plus 6x squared y squared divided by negative 3x squared. Okay, 3 divided by negative 3. Sort of. You have a positive divided by a negative. It becomes negative. So negative 1 x to the second. Do we have questions about that term?
So they won't cancel out?
The 3's do, but a positive divided by a negative is a negative. So we do either need to put just a negative sign, or you can put a negative 1. If you would rather just write it as negative x squared instead of negative 1x squared, that's the same thing. Okay, they don't completely cancel out unless they're exactly the same.
So the next one would be -3.
So we've got a subtraction sign and then a -3. So what does it really become?
3.
A positive. Are we all seeing that? We've got minus. This becomes a negative. So subtracting a negative, we're going to turn it into adding. All right. What happens with the x's? X to what power? The first power. X to the first. So 3 minus 2 would give us x to the first. What else needs to be there? The y. Six divided by -3 would be -2. What happens with my x's? They cancel. What still needs to be there? Y squared. Now, we need to clean this up just a little bit because I don't want to see plus a negative. How should we write that? What is it, Jasha? Yes, it turns into subtraction. Adding a negative is the same as subtracting. So if you're adding a -2, that's the same as subtracting 2. Okay, so this should be what our final answer looks like. I wouldn't necessarily take off points if you have my plus a negative there, but we should clean it up to just have one sign. No questions? Okay, so we're going to use this for what we're doing on the back. We say that one polynomial is evenly divisible or just divisible by another polynomial or monomial if the quotient is also a polynomial. So remember the problem where we ended up with fractions in our answer on the front? Where we had like 4 over y and all of that? We're not going to want that if it's going to be evenly divisible. Kind of like we don't want remainders when we divide. So if you want to make a note of that, no fractions. Our answer shouldn't have fractions if it's evenly divisible. Okay, to factor a polynomial, we must find the GCF of all the terms. So notice how it says all the terms. So if there are 3 terms or 4 terms, we've got to find the GCF of all of them, not just 2 of them. So let's give this a try. We are asked to factor 16y minus 12. So we are going to divide both of these terms by the GCF. Remember, factor means to write it as a multiplication problem. That's what we're going to do. Some people also think about this as undistributing. Does anybody know the biggest number we could divide both 16 and 12 by? Dominic?
4.
4 would be correct. So if we didn't know that, 16y would be 2 times 2 times 2 times 2 times y. 12 would be 2 times 2 times 3 we'd have 2 pairs of 2s, so that's how we know that the GCF is 4. Okay. Are we all okay with the GCF here being 4? That's the biggest number we could divide both of those by. So if we're dividing both of these by 4, then to write it as a multiplication problem, I'm going to need a 4 in front of the parentheses. And I write the leftover part inside the parentheses. So if I take 16y divided by 4, what do I get? 4y minus, if I take 12 divided by 4, I get 3. That's our answer. That's how we factor. We wrote it as a multiplication problem. Okay, so it'll always be your GCF outside the parentheses and whatever you get after you divide inside the parentheses. Okay, so on the front, we were just dividing. We didn't have to write it then as a multiplication problem.
This part. Is that the same as that? From the part? Is that the same as that? Word.
So we found a GCF. That part's the same. But then we took it one step further and actually divided both of the terms by the GCF.
So that one when it says GCF, we have to multiply that.
Again, we are going to write this as a multiplication problem. So the first thing we need to know is the GCF.
Times 2 is 4.
Okay, so we could rewrite 4x as 2 times 2 times x.
And this one is 2 times 10.
2 times 2 times.
So we could break it down to 2 times 10, but 10's not prime, so we got to break down 10.
5 times 2.
Okay. So to break down 20y, it would be 2 times 2 times 5 times y. Prime factorization. Do we have questions about it? So what do we have matches of?
2.
Okay. Okay. Do we put the xy on that 4? No, because they didn't match. Right? We only put matches for our GCF. So we're going to divide both of these by that GCF, which is 4. Our GCF gets written outside of some parentheses. And our leftover, or whatever we have after we divide, is inside. So if we take 4x divided by 4, what's left over? 1x, or just x, plus 5y. That's the answer. GCF on the outside, leftovers after we divide on the inside. Do we need more time with 7, or are we ready to try 8? Ready for 8? Okay. If I break 5x squared into its prime factorization, what's it going to be?
5.
So we don't ever put 1 on there. 5 times
X.
times.
Can I put them on there?
You can, but it's kind of a waste of time. Okay, what about 10?
5 times 2.
Okay. What do we have matches of?
X.
And x. So that's what we divide by. Our GCF is 5x. That's what we're going to divide both of these by. That's what we're going to write outside of some parentheses. The leftovers after we divide go in the parentheses. So what's left over?
X.
X plus 2. Should the 2 have an X?
No.
No, because they would have canceled out completely there. That's our answer. Oop, box. There we go.
Oh, wait.
Questions?
Oh.
This is getting a little better as we go. Some people act like it is, some people not so much. How many terms do we have this time? 3. So our matches have to happen on all 3 of our lists.
2.
So if I break down 28, what would it break into?
2.
2 and
13? No.
2 and 14. 14 breaks into,
72.
okay. So for 25 or 28, 8 to the 5th, I'd have 2 times 2 times 7 times how many A's?
5.
5 of them. Okay, we also need to break down 12a cubed. Does anybody remember the prime factorization for 12?
2.
Times,
2.
times,
2.
no. 2 times 2 is 4. 4 times what would give me
3.
that 12? 3. How many A's?
3.
So that's not negative?
We don't need to treat it like a negative. We can just remember that the negative sign will go in our answer when we make our parentheses. There will be a negative in there.
2 times 5.
Yeah, you lost.
We don't need to treat the 12 like a negative. We can treat that like a subtraction sign and treat the 12a cubed as its own term. So we'll have a negative or a minus sign inside our parentheses there. We don't need to have a negative on our list. All right, what about for 20?
12. I mean, 2 times 10.
10's not prime though.
2.
So if we break it into 2 and 10, 10 has to break
5
into
and 2.
2 and 5. So we really have 2 times
5 times 2 times 5.
how many A's?
2.
2 of them. Okay, so we've got our lists of our prime factorizations. Now we need things to match up on all of our lists. How many sets of 2's?
2.
2 sets of 2's. So 2 times 2.
3, 6, 8.
How many sets of A's?
Oh, 2 sets.
2 sets of A's. So we're going to have 2 times 2 times A. What is that when we simplify it? 4A squared. That's my GCF. Okay, so I'm going to divide each of these terms by my GCF. Where else does the GCF get written? Outside my parentheses. So outside here, I'll have 4A squared. Okay, 28 divided by 4.
14. Wait,
Careful.
no.
If you look on your GCF list, it kind of helps you out because
7.
7. That's what we didn't use up. So 28 divided by 4 is that leftover 7.
Oh, so your answers are the ones that are left over?
No.
Okay, so A to the 5th divided by A squared would give me
7.
a cube. Notice that we had 3 A's that weren't in matches. Now here's where that minus sign comes into play.
Negative.
So we put that minus sign over here
Negative 3.
because it was minus. So yes, there would be a 3A to the first power. So we could just put minus 3A.
Was.
And then on the last term,
Plus 5.
plus 5. Any A's?
No.
No, they canceled out totally.
Okay, this is understandable.
Questions, concerns? We're sure? Okay, let's try another one. Anybody think they know the GCF of 15 and 20? 5. Okay. So we know they're both going to be divisible by 5. How many x's do you think they would be divisible by? X to what power? 2. Okay, this one's got 2, this one's got 3. So if we were to make the lists, this one's got 3, this one's got 2 of them. So x squared. Y to what power? The first. Okay, this one gets limited here. It's only got one y to give up. Z to the first, good. Again, this one is limiting it. It's only got one to give up. Okay, if you need to write out your lists like we've done on the last few problems, you can, but hopefully you're getting to the point where you don't have to do that every single time. So, where else does that GCF get written?
On the outside.
Outside some parentheses. Inside those parentheses, what do I have? Probably need to write that down here because I'm not going to have enough space. X squared yz.
So that's 3.
Yep, 15 divided by 5 is 3.
First power.
X would have a first power. Y would have a first power. What happens to the z's? They totally cancel. Bring down that minus sign. Y, is there no X or Y there? Why just 4Z? Good, they cancel out completely when they totally match. Questions, concerns about number 10?
Do we have to do all the problems?
Yes. I will give you a few minutes to try the next problems on your own. We will talk about them in a couple minutes. Remember that your answer includes that GCF on the outside and the parentheses with the leftovers on the inside. If you only have part of that, you don't get all your points. Your answer is that whole thing. We're writing it as a multiplication problem.